Section 10.5, counting problems involving not and or. Complements counting principle. If A is a subset of a universal set U, then the number of elements in A is n sub U minus n sub A prime. That's the number of elements in the universe minus the number of elements not in A, and we'll find the number of elements in A. The formula n, the number of elements in A equals the number of elements in the universal set minus the number of elements not in A. Number of subsets of a set N. A set that has n elements has 2 to the n subsets. We take the number of elements in the set, do 2 to that number power, and we find out how many subsets there are of that set. The number of proper subsets, subsets that are not the set itself, of a set is 2 to the n minus 1. Example 1. 4 fair coins are tossed. How many ways can you get at least one tail? If you get at least one tail, the opposite is getting no tails. Getting no tails is all heads. There is only one way to get all heads. Heads, 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 heads. The number of outcomes of tossing 4 fair coins by the fundamental counting principle is 2 times 2 times 2 times 2, which is 16. Take away that one way to get all heads, 16 minus 1. There are 15 ways to get at least one tail. Example 2. Carol and 3 friends are boarding an airliner just before departure time. 10 seats are unoccupied. 3 are aisle seats. How many ways can the 4 friends arrange themselves in the available seats so that at least one of them sits in an aisle seat? Using permutations, order matters. Different people in different seats changes things. At least one aisle seat is the opposite of no aisle seats. 10p4, 5040. The number of ways to arrange 4 people among 7 non-aisle seats is 7 permutation 4, 840. The number of arrangements with at least one aisle seat is found by subtracting. Permutation 10-4, permutation 7-4, 5040 minus 840 is 4,200 ways that at least one friend sits in an aisle seat. The additive counting principle. Let A and B be sets. The number of elements in the union of A and B is the number of elements in A plus the number of elements in B minus the number of elements in the intersection of A and B. The number of elements in the union of sets A and B is the number of elements in A plus the number of elements of B minus the number of elements in the intersection of A and B. Example 3. How many 5-card poker hands consist of either all clubs or all red cards? Since clubs are black, it's impossible to have a 5-card hand of red clubs. There are 13 clubs and 26 red cards. Order does not matter, so we are using combinations. 13 clubs, so we're going to do 13, choose 5, plus 26 red cards, choose 5. Calculating those combinations, it's 1,287 plus 65,780. There are 67,067 5-card poker hands of either all clubs or all red cards. Example 4. The political party affiliation and gender of 18 congressional members is given by the following table. If one congressional member is chosen at random, how many ways could that person be a Democrat or a woman? So the number of Democrats or women is the number of the union of Democrats and women. That is the number of Democrats plus the number of women minus their intersection. We don't want to count people twice. There are 10 Democrats. There are 9 women. And there are 6 that are both Democrats and women. 10 plus 9 minus 6 is 13. Chrissy needs 12 specific courses to complete her degree, 4 in math, 3 in physics, 3 in computer science, and 2 in business. If 5 of these courses are chosen at random for next semester, how many selections contain at least 2 math classes? She can take 2 math courses, 3 math courses, or 4 math courses. If she takes 2 math courses, there are 4 that she can choose from, and that leaves her with 10 other classes that she's going to choose 3 of. Calculating those combinations is 6 times 56 and 336. If she takes 3 math courses, there are 4 math courses and she can choose 3 of them. Then there are going to be 9 courses that she can choose 2 of. 4 times 28 is 112. If she takes 4 math courses, there's 4 math courses and she's going to choose all 4. There are 8 other courses that she's going to choose 1 of. 1 times 8 is 8. The total number of selections that contain at least 2 math courses is 336 plus 112 plus 8, which is 456. Example 6. How many 3-digit counting numbers are multiples of 2 or 5? A multiple of 2 must end in 0, 2, 4, 6, or 8. A 3-digit number. There are 9 choices for the first slot, 10 choices for the second, and for it to be a multiple of 2, there are 5 choices for the last slot. It's 450. 3-digit numbers that are multiples of 2. A multiple of 5 must end in a 0 or a 5. Again, a 3-digit number. It's going to be 9 times 10 times 2. There are 2 options for it to be a multiple of 5. It's 180. Multiples of 10 were counted twice, ended in 0 for the multiples of 2, and ended in 0 for the multiples of 5. 3-digit number. 9 times 10 times 1 is 90. So we're going to do multiples of 2 plus multiples of 5 minus multiples of 10. 450 plus 180 minus 90. The answer is 540. There are 540 3-digit counting numbers that are multiples of 2 or 5. Example 7. A single card is drawn from a standard deck of 52 cards. How many ways can it be a heart or a king? 13 cards are hearts, 4 cards are kings, 1 card is a heart and a king. 13 plus 4 minus 1. There are 16 ways drawing a card. It can be a heart or a king. A single card is drawn from a standard deck of 52 cards. How many ways could it be a club or a face card? 13 cards are clubs. 12 cards are face cards. 3 cards are clubs and face cards. 13 plus 12 minus 3, 22 ways. Example 9. How many subsets of a 25-element set have more than 3 elements? How many subsets have 0 elements? Doesn't matter the order, so it's 25, choose 0, which is 1. How many subsets have 1 element? 25, choose 1, and there are 25 subsets with 1 element. How many subsets have 2 elements? 25, choose 2, 300. How many subsets have 3 elements? 25, choose 3, 2,300. How many subsets are there of a 25-element set? 2 to the 25th power, which is 33,554,432. How many subsets have 0, 1, 2, or 3 elements? 1, 25, 300 plus 2,300. 2,626 subsets have 0, 1, 2, or 3 elements. How many subsets have more than 3 elements? We're going to subtract. There are 33,551,806 subsets that have more than 3 elements. That's section 10.5, counting problems involving not and or.